All right, in this video, we're going to start with looking at quadratic formulas. Now, we're looking at your pink notes right now, and you should have your linear function on there. You should have the absolute value function completed. And so today, we're going to start with the quadratic. So this is note 7.1, and we're starting with quadratics. Now, with quadratics, maybe you learned this to remember this from Algebra 1. It is the function of y equals x squared. It makes a parabola shape. So when we plot our points, we're going to start with the origin at 0, 0. And if my x value is 1, if I plug a 1 in my equation for x and squared, I get a 1. If I plug a 2 in my equation, I get a 4. So it goes up 1, 2, 3, 4. And then on the negative side, if I put in a negative 1 in squared, I get a positive 1. If I put a negative 2 in there, I get a positive 4. So you can see the parabola shape. Got to have the arrows at the end and the nice curved shape. Now the points that you want to make sure you always use to start with are 0, 0, 1, 1, x is 2, y is 4, and then the negative side, negative 1 squared gives me a positive 1, negative 2 squared gives me a positive 4. So these are going to be the main points you want to use, and you're going to use this relationship of go up 1, over 2, up 4. So these values are going to help us as we graph transformations of quadratic functions. So let's go back to listing out domain and range and all the things we need to do in both set notation and interval notation. So our domain, recall that our arrows are going this way, so that means all x values will be used. So we would set our notation as x such that x is an element of all real numbers. Remember, in interval notation, it looks like this, negative infinity to positive infinity. My range is the lowest y value to the highest. Well, the lowest y value is 0, so it's going to be y such that y is greater than or equal to 0. And I'm going to put a hard stop on that 0, so it's a bracket, comma, positive infinity. Now the x-intercept, where does it touch the x-axis? That's at 0, 0. And my y-intercept is at 0, 0. Okay, and this one has no asymptotes, so you would write none. So we're going to use this parent function to help us do our transformations of quadratics. So these, again, these points in this relationship right here are going to be really key for you as we graph our transformed points. All right, let's look at the lesson page 471. Okay, here we go. So here's the equation for vertex form of a parabola. So let's break this equation down a little bit. Now this a value is very similar to what we did with the absolute value graph. It is going to be the vertical stretch or shrink. And remember, if a is, it goes with logic, so if a is big, then it's going to stretch it. If it's small, like between 0 and 1, it's going to shrink it. H is what's happening left and right. Okay, it's opposite logic, remember? The K is the vertical shift. It's either going up or down, and it goes with logic. So this formula is called vertex form because you can look at it and see the H and the K, which is your vertex. H and K. Now, H, you got to remember that you have to change the sign on that H. Now, K is exactly the way it appears in the equation, but the H does change. Now the axis of symmetry is going to be x equals, and it's going to be h. Whatever that h value is in your vertex, that's what you're going to use for your axis of symmetry. Now let's look at this a value for a second. Right there, that a value in the front, if it's greater than 0, then the graph opens up. Okay, and by greater than 0, I mean positive. If it's positive, it's going to open up, and This vertex down here is at the bottom, and we call that the minimum. So if a is less than 0, that's a fancy way of saying if a is negative, that means our parabola is going to open down. And you can imagine that vertex right here is not a minimum, but now we call it a maximum. Okay, so let's look at the rest of our paper and see what it is we're going to be doing today. So let's break down our instructions for a moment. It says state the vertex, then graph each function, state transformations from the parent function and the domain and range for each in set notation. All right. So let's first go through all of these and just do the vertex. All right, let's just do the vertex and you'll see how handy the vertex form is. So the vertex is going to be, remember, it's H and K. From up here, it's H and K. I remember the order with Hello Kitty, H and K. So I look in the same location in my equation for H and K. And I just remember I need to change the sign of H. So it's not -5, it's going to be 5. And then the K part stays the same, so it's 5, -2. Let's just run through all these and do vertex really quick. So let's look at number 2. Look at my H. It says -1 there, so my vertex, it's going to be actually a +1. There's nothing added or subtracted, so it's 0 for K. On number 3, notice there's no parentheses there with the x squared. That means that my H value is 0. The +4 is hanging off the back end, so that's my K value, so 0, 4. Come back over here to number 4. My H value, that +2, I got to change the sign, it's -2, and that 1 hangs off the back. Number 5, it says -3 in the equation, but I know that's going to be a +3 and a +4 for K. And then number 6 down here, it has a vertex of -1 and -5. So that's how we find our vertex. Hopefully you found that to be pretty straightforward. Then it says to graph each function. State the transformations from the parent function and domain and range. So let's do that middle section. Let's state the transformations and graph them. So let's look at number 1. So that -5 inside, remember in the parentheses, it's going to go opposite logic. So this is going to move right 5. The -2 means going to move down 2. All right, so I know my vertex is at 5, -2, so I'm going to move it there. 1, 2, 3, 4, 5, down 2. And my A value, notice it's not written, but that just means it's a +1, so it's the regular slope. And this is where you want to remember that parent function. Remember it went up 1 over 1, 1 and 1, and then went over 2, we went up 4. That stays the same. And then you might consider this. So this is 1/2 of your parabola, right? Well, it's symmetrical. So if you want to consider this axis of symmetry, if you imagine a dotted line right here, and you just reflect it across, it's going to go up 1 over 1 to the left, up 2 over 2, up 4 on the right, on the left again. So here we go. So there's my transformed parabola. Let's look at number 2. Our vertex is at 1, 0, and our A value is just 1. So transformations, what has happened? It's only moved right 1 unit. It hasn't moved up or down. So remember our parent points, we went over 1, up 1, over 2, up 4. That hasn't changed because that A value is the same. So I'm going to do the same thing on the left side. Over 1, up 1, over 2, up 1, 4. And I'm going to draw my curved line with my arrows. There's my new equation. Let's try number 3. This one, the vertex we said is at 0, 4. 1, 2, 3, 4. So what has happened? All that's happened is it's moved up 4 units. Now, that A value is not written because it's just a regular old 1, which means it's going to look like the parent function. It's going to go up 1, over 1, up 1. Over 2, up 4. And then I do it on the other direction. Over 1, up 1, over 2, up 4. All right, so far no big changes in the slope, okay? No big deal, but let's try some more challenging ones. Let's look at number 4. All right, this one has a vertex at -2, +1. Now, notice what transformation. Remember this lead negative? That means it's going to reflect over the x-axis. What's happened? It has moved left 2 units and it's moved up 1 unit. So it's going to open down. That means it's going to open down. And it's opening down, but it's the A value is just 1. So it's going to go over 1, down 1, over 2, down 4. And then do the same thing going down the left side, over 1, down 1, over 2, down 4, and draw a smooth curve with arrows connecting. And there's our transformed parabola. Let's look at number 5. We know our vertex is at 3, 4. 1, 2, 3, 1. All right, so let's think about the transformations that are going on. We've moved right 3. We moved up 4. That 2, that A value right there, means it's a vertical stretch by 2. The negative is doing something different. That's a reflection over the x-axis. So it's flipping upside down. So let's see what happens. We know it's going to go upside down, but now how do we handle this vertical stretch? Well, whatever that value is for A, what you're going to do is multiply it by the y value. So A times the y's. That's what we're going to do. So I'm going to show you how to do that. So typically, we would go over 1, down 1, right? And over 2, down 4. However, going down 1 is from the parent function. That 1 is what I need to multiply by A. So in this case, 1 times 2 gives me 2. So I'm going to go down 2 instead. 1, 2. And instead of going down 4, I'm going to multiply that 4 by 2 and get 8. And then I'm going to do the same thing going down the left side. So down 1, over 1, down 2, over 2, down 8. That's why those original parent functions are really important when we get to these other shapes. All right, so there's my parabola. Let's try the next one. Let's relocate our vertex, so it's -1, -5. All right, let's list the transformations going on. It's gone left 1, down 5. That takes care of that and that. Now it's going to be a vertical shrink by 1/2. So watch what happens. Typically we would go over 1, up 1. But remember, we're going to take that 1/2 and multiply it by the y's. So instead of going up 1, we're going to go 1 times 1/2. So it's going to go up half. Over 2, we typically go up 4, but half of 4 is 2. So I'm going to go to 2. So there's this side of my parabola. And the same thing's going to happen on the left. We're going to go up half, and then we go over 2, up 2. So you can see it made my parabola a little bit short and squatty, but that's what a vertical shrink does. Now let's go back to the top and look at what else we need to do. We've stated the transformations, we've graphed everything, the vertex. Now let's do domain and range. So looking at number 1, you should notice that the arrows mean that it's going to go left and right. So my domain is going to be all numbers, so x such that x is an element of all real numbers. So that's always going to be the truth for parabolas, by the way. Now my range is what's going to change. So let's look at this. Where's the lowest value of this? Well, it's right here. That's where y is -2. That means that y is greater than or equal to -2. That's a minimum, right? So we will deal with that more later, but that's a minimum. Let's try number 2. My domain and range. Okay, my domain, thankfully, parabolas have no restrictions on domain. So x such that is an element of all real numbers. Range, where's the lowest value? It's at 0. So y, such that y is greater than or equal to 0. Number 3, my domain, x, is all real numbers. Collapse it down, it's never going to miss an x value. And then my range, all right, where's my lowest value? It's 1, 2, 3, 4. So y is greater than or equal to 4. Let's jump back up to number 4. Domain, again, left and right. We're good to go. X is an element of all real numbers. The range, notice it has, this is now a maximum, right? So it's going to be, the highest it's going to be is a 1. So it's y such that y is less than or equal to 1. It does exist at 1, and then it gets smaller. On number 5, my domain is all real numbers again. You should see a pattern here. My range, look at this, here's a max, right? A maximum value. What's the maximum? Well, it's up at 4. But y's are getting smaller, so y is less than or equal to a 4 from there. And then let's look at number 6. Domain, x such that x is an element of all real numbers. Range, all right, what's going on here? It goes down to, what, -5? But then my y values get higher, so y is greater than or equal to a -5. All right, hopefully this is getting easier with domain and range. So let's look at the next part of your paper. Write a quadratic function matching the description given. So the parent function is stretched vertically by a factor of 8. Okay, so that factor of 8 is my a value. That means it's going in front. Translated 7 units down, so this is at the end of the equation. It's going to be a -7. 3 units right, that's going in the parentheses, but it's going to be opposite logic. So instead of, if it's going right, it's going to be a -3. And then reflected over the x-axis means it's a lead negative. Okay. So let's write this equation. It's going to be y equals, so 8 goes in the front, and it's negative, a lead negative, so -8. And then it's going to be the x minus 3, but I have to have it squared, and then a -7. Now, don't forget the squared. This makes it quadratic. A lot of students, quadratic. A lot of students make a mistake here and forget that squared, so don't forget that, all right? Let's continue on with number 8. Without graphing, identify the vertex, the axis of symmetry, and transformations from the parent function. So, vertex, remember here's h, and k is back here on the back end, so it must be 0. So h is 4, k is 0. Axis of symmetry is always x equals h, which is 4. And the transformations, well, it's pretty simple. It's going opposite logic, so it's going to move right 4 units. All right, this last one is looking at these graphs and writing the quadratic equation that goes with it, okay? So let's look at this. Let's analyze this. So here's our vertex. So what is it? Over 2, up 2? So at 2, 2 is my vertex. So I know I'm going to have x minus 2 squared plus 2. Now I need to decide, is there an a value? So is it just going over 1, up 1? Over 2, up 4? It is. So it's following the parent function pattern. So the a value is just 1. And we know that it's opening up, so it's just positive. So it's just y equals x minus 2 squared plus 2. Let's look at 10. My vertex, let's see, it's at -4, 2. So I know I'm going to have x plus 4 squared plus 2. That's my vertex part of it. Now let's look at the a and what's going on in the front here. Now notice it's opening down, so we know it's negative, right? Now let's look at this. Is it going over 1, down 1? Not quite. It's only going halfway. So if it is halfway, if you go over 2, it should go down 2, right? So that looks like it's a 1/2. Negative 1/2 x plus 4 squared plus 2. So it's all right, so here's our answer. I hope this is making sense, and let me know what questions you have when we get to class.